In this lecture, we'll be working with quadratic equations and learning different methods to solve quadratic equations. We'll also be using calculators a lot to graph quadratic equations, so go ahead and get out your graphing calculator as well while we're working. So first of all, before we start solving quadratic equations, it might be a good idea to know what one is. So a quadratic equation, you might look at this prefix quad and think it means 4, but it actually means to square. So in Latin, the word quadratus means to square. So again, we're not looking for quad. We're used to like a quad, like a four-wheeler meaning 4, but this is quadratus in Latin, which means to square. So we're looking at equations that the first term or the highest term is squared. So for example, x squared plus 2x plus 3 equals 2. That's a quadratic equation. Now it's called equation because of the equal sign. Now just because I have an x squared, I don't have to have the rest of this. I could also have just an equation like 2x squared equals 0. So it doesn't tell you the number of terms you have, it just tells you that the highest power in the equation is squared. So that's what quadratic has to do with. Now when you graph a quadratic equation, you get a parabola that opens up. Let's say if we have something like 2x squared is a parabola that opens up. And then if I have something like a negative 2x squared, the leading coefficient on my quadratic term is negative, I get something that looks like a parabola opening down. So when we start graphing with your calculators, we should see some shapes like this, and if you don't, that means we need to change the viewing window of your calculator to make sure we can see everything. Now one other quick note, in your My Math Lab homework, a lot of times they'll say solve using a particular method. Well, you can use any method you want. The My Math Lab doesn't know what method you're using. So my recommendation would be you decide what method you want to use based on what method you're best at. Now there's one other thing that we're going to need to know today, and that's the quadratic formula. And this is one that you'll need to have memorized for exams. And we'll explain how to use the quadratic formula a little bit later in the lesson, but I want to make sure that you have it right up front. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac is all underneath the radical sign, and this entire fraction is all over 2a. So quadratic formula, make sure that you know it and make sure that you have it memorized. It'll be very handy to have. So we're going to get started just by solving lots of quadratic equations. Now again, My Math Lab might tell you what method to use, but you can use any method you want. So we'll look at each one and decide what method looks best. So let's go ahead and solve this quadratic equation. Let's try x squared minus 2x minus 24 equals 0. And let's go ahead and think about this one. Let's solve this one by graphing. Now, when we're using our calculators, the calculators will help us check our work, and sometimes they'll actually help us solve depending on what the solutions are. So as we get started with graphing, the first thing we want to do is learn how to graph using your graphing calculator. So when you graph, and you're going to basically be using these keys in the top row for your graphing commands, and then you're going to be also using this variable x right here for your x key. So to start graphing, you hit y equal. If you already have an equation in here and you don't want it, you can click clear. And we're going to be graphing x squared. So here's your x key. So x exponent squared. Now if you have a caret there, that's fine as well. Minus 2x minus 24. Now I don't have to put in the equals 0 because this is already y equal, so that's already taken care of. When we get into a little bit more complicated expressions, the thing we need to realize is that everything needs to be on one side. We need to get everything set equal to 0 before we can graph. So let's go ahead and hit graph. Now your output might look different than mine. This kind of depends on what your viewing window is. And you can see we have this shape of the parabola opening up. The problem is, it looks like to me we need to see a little bit more. So I'm going to go over here to Window, and there's a lot of different ways that you can do this. And if you notice, my x min is negative 10, my y min is 10, but look at my y min, it's negative 275. I think I just would like to change that to a negative 10. And so my y max will be a positive 10, and then I can see I have my nice viewing window down here. It does look like I do need to go down a little bit lower on my y min if I want to see the vertex of this parabola. That means the lowest point in this case. So let's try negative 50. Well, maybe they had that negative value in there for a reason. Let's go 275. And again, I'm just choosing values here and guessing and checking until I can see my complete graph. Yeah, well, that's way too low. So you can see that this is a matter of guess and check. And again, I'm looking for that minimum y value. I think I might want to try negative 100 maybe. That one's a little better. I think I'm going to change it again. Let's go negative 50 maybe. And this is how you change the scale whenever you're working. So if you can't see your complete graph, you can come in here and change your different scales. Okay, this looks a little bit better. We can see the vertex here, and I can also see some of what's going on up here. So that's how we graph an equation, any equation. In this case, it's a quadratic equation. Now, some of the important features on this graph, right here where it crosses at negative 1, negative 2, negative 3, negative 4, that's one of my roots. That's one of the things that solves this equation. There's two roots to this equation, negative 4, and if I count over here, positive 6. Those are my roots. Now I can see that they cross here really clearly, but I want to double check. Now, not all equations will have nice integer solutions. So if I want to double check those, one thing that I can do is I can go to second. Up above the graph key is the table key, and I want to hit second graph to get my table. And I'm looking right here for my solutions, and I see right away negative 4, 0 is a solution. That's where it crosses the x-axis at negative 4, y is 0. And if I scroll down, and I'm looking for that other 0, and notice this goes from positive to 0 to negative, and now my y values are going from negative to 0 to positive. That will always happen when you cross an axis. It goes from negative to positive. So I can see my other root here is at 6, 0. So I can see it in the graph, and I can see it in the table. Now, another way I can find this root is by going to second calc. And then I have a couple of options here. I have value, 0, minimum, maximum, etc. The one that we want to focus on here is 0. And 0 means where does it cross the x-axis? Well, right now it's asking for the left bound here. You can see this on the bottom left-hand side of the screen. I want to find this point up here, and I know it's negative 4, but let's see how the calculator will find it. I want to find this value, so I need to go to the left of it. So I can arrow over, and you can see that little asterisk moving. And I can see now that I'm to the left of it. It can be anywhere to the left. And then you hit enter, and now it's saying to the right of it. So let's move a little bit to the right, hit enter, and now it says to guess. And to guess, you can just leave it where it's at right now, or you can move the cursor to where you think it's closest. Hit enter, and it tells me my solution, negative 4, 0. So these are a few nice little things to find these zeros for the function. Now let's go ahead and find the one on the right. And again, we know it's 6, but let's see how we can go through this process. We choose second calc, choose my 0 function, and again, I want to be to the left. And I am to the left right now of my 6 value. And I want to get a little closer, and again, I know my answer already. We're just verifying it, so when we get into problems that are a little more difficult, I still have the same process. So we did a left endpoint, right endpoint, there's my guess, and it tells me my 0 is right here at 6, 0. So these are important ways that we can do problems. We can graph and see the intersections, and we can also check our answers as well. So let's go ahead and pop this graph into our lecture and make some notes on it. As usual, they come in way too big. Now, there's a couple of other features about this graph if you solve quadratic equations that we'll see when we actually factor. So, one solution that I can get from graphing is 6, and the other one is -4, because that's where it crosses. Now, you always have to check to make sure they're integer values and not some decimal. So, my solutions here are x equal -4, comma 6. Now in my math lab, they usually already provide the x equal. You just need to include the -4 and 6, and we always like to order those from smallest to largest. So we start with the -4 and move up towards 6. Now a couple of other things. Here I have x squared minus 2x minus 24 equals 0. I could have also solved this by factoring. So this is another method I could have used. And again, my math lab doesn't know what method you use, so choose what method you like best. So I want to do the reverse FOIL on this, or the box method, or the AC method, depending on what you learned in Math 095, or the reverse FOIL again. If we take a -6 times a +4, I'll get -24. And if I take a -6 plus 4, I have my -2. So this is factored correctly. And then what I do is I apply the zero factor property. Either one or both of these factors must equal 0. So again, this is called the zero factor property. It's really handy, and we'll be using this quite a bit. So if I have x minus 6 equals 0, I would add 6 to both sides, and I'd have x equals 6. If I have x plus 4 equals 0, I would subtract 4 from both sides, and I get x equal -4. And we can see here then from these two solutions, I get the same set of solutions, x equal -4, 6. And basically that's saying, where does this graph cross the x-axis? Now this particular graph crossed the x-axis twice. There's no way that a quadratic equation can cross the x-axis 3 times, but it's possible that a quadratic equation could cross the x or touch the x once, and it would look something like this. So I could have one solution where it comes down and touches. So this is one solution. And then it's possible that I could have another solution where I don't cross the x-axis at all. So this is no solution, no real solution. I'd have to go into the complex number system. So the most I can have is 2 solutions. I could have one solution down to 0 real solutions. So again, we're going to be doing a lot of different methods here. We want to use our calculators to verify and check our work whenever possible as well. So we'll be popping in the calculator quite a bit here. Now one thing when you're trying to solve a quadratic equation is the first step you should always take is getting it set equal to 0. So here we have x squared equals 4x plus 12, and we're asked to solve. Well, our first step should be set equal to 0. Now sometimes we'll have some other methods where we won't do that, but when we get to one of those problems, I'll show you some of the distinguishing characteristics that you'll look for in the cases where you don't set it equal to 0. So we'd subtract 4x and 12, subtract 4x and subtract 12. So over here on the right hand side I have 0, and on the left hand side I have x squared minus 4x minus 12 equals 0. Now this one we could solve by factoring, because this does factor. Again, if you want to use the AC method or reverse FOIL or the X box, depending on how you learned to factor. 1 times 12 is 12, but there's no way that 1 and 12 combine to a 4. 2 times 6 is 12, and I can see that we could get to a 6 and a positive 2 to get us to a -4. So this is the correct factorization. So here we have x minus 6 equals 0, or x plus 2 equals 0. And again, this is basically using the zero factor property. And that zero factor property is going to come in handy a lot. So here we'd add 6 to both sides. So we have x equals 6. Here we'd subtract 2 from both sides, and I get x equal -2. So our solution set would then be x equal -2, 6. Now there is a way to know if we're right, and that's by plugging it back into our original, but we can also double check this in our calculators as well. So for this problem, let's go ahead and hit y equal again, and let's clear out what we have there. Now notice I can't put in x squared equal 4x plus 12 because on my left hand side here I already have my equal sign. So I have to put in the x squared minus 4x minus 12. So I need to put in the form here where it's already set equal to 0 before I can do anything. So let's go ahead and hit graph. And again, we might have to change our scale. Okay, so it does look like we're crossing at -2 and +6, so this seems to verify that. To verify as well, we could go to second table, and here we have a solution at -2 and 6 as well. So let's go ahead and copy this in to our notes. We'll make a couple notes there. And again, this is from our graph. So you have to input the graph before we can get the table. But we see from here that we have a solution of -2, 0. And we also have one down here at 6, 0. So where y equals 0, this is called the x-intercept. And this is called a solution or a root of our equation. So this is called the x-intercept up here as well because the y value is 0. So again, it's the solution or root of our equation. Now a lot of times when we're looking at a graph we don't get integer solutions. So far we have, but usually we don't. And so this table sometimes isn't going to help us, but it's always a good thing to check because it'll give you an idea, at least if not exactly what your root is, where your root is located, so you can kind of estimate it. Let's go ahead and graph this as well and pull that into our notes. And then we can note on the graph where our solutions are as well. And again, our solutions are at -2 and 6. And we can see that from the table, and then we can see it from the graph. Here we are at -2, and here we are at 6. So far all the problems we've had nice little solutions, and integer solutions are nice. They're easy to find with your calculator and usually by factoring, but sometimes we'll run into some cases where they don't work so well. Let's go ahead and look at an example where we're asked to solve a quadratic. This one is 45 minus 45x equals, now we have a product of two binomials, 7x plus 4 times x minus 1. Now we could solve this by factoring, and in fact when you run across this type of question it will say solve by factoring, but again my math lab doesn't know how you're solving, so solve any way you want. So if you wanted to solve this by factoring, what you would do is expand the right hand side, move everything over to the right, set it equal to 0, and then hopefully it factors. I would like to graph this on your calculator. And if we get a nice integer solution, we can be done. If we get fractions and decimals, we might have to go back and do some handwork. So I think it's always a good idea to graph these right away. Now remember, when you graph, these have to be set equal to 0. So I would have to subtract 45 and add 45x. So subtract 45 and add 45x. So I have 0 equals the product, 7x plus 4 times x minus 1 minus 45 plus 45x. So this is what I will graph. It has to be set equal to 0. So let's go ahead and jump into your graphing calculator. And again, after you hit y equal, if there's anything in here, you can just hit your clear button. We have 7x plus 4. We have to have our parentheses up here. X minus 1. And then remember, we had to subtract 45 and then add the 45x because it has to be set equal to 0. Now, we might have to change our scale here. We might not see where it crosses. Well, let's see if we can give it a try. Okay, it looks like it's crossing at a negative value and a positive value. Now when we're looking at this trying to find our roots, I see something interesting here in the table. And again, if you want to see this table, you'd go to second table. I see it here at -3. This graph goes clear down to 112. So I'm going to scroll. So if you notice, the smallest this ever gets in our y direction is -112. So if I wanted to change my viewing window and I wanted to include that minimum, I could just come down here to y min, the y minimum value, and I could do something like -120. Now remember, we just need to make sure it clears -112. And then I can see a little bit more of the graph. I can see that vertex. This is called the vertex of the parabola, and I can see our roots as well. I can also see our roots here at 1, 0, and then I probably have to scroll a little bit under second table to see our other root, because it's clear over here at 7, I believe. No, wait, it's at 1, 0. We'll go the other way. There we are. So both of our roots are showing now. So let's go ahead and grab this. We can see this in the table. Find our roots that way. And then we can also pull in the graph to see where it's crossing the x-axis. And where it's crossing the x-axis are also our solutions. So we'll make note of those solutions here in the table and then in our graph as well. So let's go ahead and look at that graph one more time. And if you want to find these, you know, if we can't see that these are integer values from the table or just by counting, you could go to second calc and use your 0 function as well. So let's pull this graph in. And it's going to give us the same information. Oversized, of course. So you could solve this by hand, or you could solve it by graphing. Either way, you're going to get the correct solution here. Here we have a root, our solution, because y is 0, so that means it's where it's crossing the x-axis, and here I have another one. So I can see it from the table, and then I can see it from over here as well. X equal +1, and here x equal -7. So my solution to this equation is x equal -7, 1. And again, you list these in order from smallest to largest. So these are long problems, and it's going to be really helpful every single time you get one of these problems. Graph it right away, and then make sure you can get a good look at what potential solutions are. You know, maybe you're looking for one solution, maybe you're looking for 2 solutions. A picture will really help here. Now this one we could solve using a different method, or we could still graph it, either one. But this one they say to solve using the square root property. So I'll show you what the square root property is. But remember, you can also use graphing. So my recommendation would be to graph this right away and have a look at it and see what's going on. So I have 5x squared equals 80. Now whenever you have a single term on one side and a single term on the other, sometimes taking the square root is the fastest way to get to our solutions. So for this one, we could isolate the x squared by dividing both sides through by 5, and I get x squared equals 16. And then our next step would be to take the square root of both sides, and I get x equal +or-4. So bingo, we're done. That's the square root property. Now, if we were going to use this for graphing, remember, I'd have to make sure I subtracted the 80 over and it was set equal to 0. So let's go ahead and jump into our graph, 5x squared minus 80. Clear that out. So 5x squared minus 80. Again, we hit our graph key. We might have to adjust some things here. Goes clear down. This is because of the minus 80. So again, this is the vertex of the parabola. And then I can see my solutions here at -4 and +4. And I can also see over here on my screen 1, 2, 3, 4. Another solution that must be for my old graph. Let's hit second table so we can see the new -4 and +4. Let's get them both on the screen here. Yeah, there we can see both solutions. So let's go ahead and pop those into our notes as well. so we can see our solutions from here, and then we'll also look at them from a graph. So these are all the ordered pairs that basically are used to graph this quadratic equation, and there's a couple that cross the x-axis, and those ones that cross the x-axis are called our solutions. I'll hit graph again so I can copy this one. See if I can get one without all that background. There we go, that one looks cleaner. And we'll paste this in as well. So definitely using the recommended square root property is a great idea, but I would graph it too just to double check your work, because again you can see a solution here at -4 and we can see a solution here at +4 in our table, and then we can also see the same solutions here at -4 and at +4 here. So x equal ±4 for my solutions here. Now just a quick note, in my math lab there is no symbol for plus or minus, so in my math lab the way we would enter this, they would have the x equal for you, and you'd go -4, 4, because they don't have the plus or minus 4 bit. So hopefully you have a little bit of background here with the square root property and also using your calculators for graphing and checking roots. Now we're going to get into some more complicated problems where my calculator will show me that I have 2 solutions, but they're not integer solutions, so I kind of run into some trouble. So let's go ahead and solve this one as well. And the recommendation is using the square root property. And again, we don't have to use the square root property. We can use a lot of different methods. We haven't even used the quadratic formula yet, but we could even use the quadratic formula or completing the square, all sorts of different things. So I have 2 times the quantity, x plus 2, quantity squared equals 90. So here I'm going to do the same thing. I have single terms on either side, so I'm going to isolate my quadratic by dividing through by 2. 2's cancel. And I have x plus 2, quantity squared equals 90 divided by 2 is 45. Okay, this has to use the square root property, so that's what I'll do next. I'll go ahead and take the square root of both sides. The square root of x plus 2 quantity squared, the square root and the squared cancel each other out. So I have x plus 2 equals plus or minus the square root of 45. Now the reason it's plus or minus is, remember, 2 squared is 4. Also, -2 times -2 is 4, so I need the primary and the negative root. Solving for x, I'd subtract 2 from both sides, cancel, and I have x equal -2 plus or minus the square root of 45. Now this answer is not complete because I can simplify this quite a bit. There's a factor of 45 that's a perfect square, and that's 9, so I could break this up into root 9, root 5. So I get x equal -2 plus or minus the square root of 9 is 3 square roots of 5. So this is my solution. Now in my math lab, remember, you can't use the plus or minus, so my math lab, I would go -2 minus 3 root 5 because that's the smaller number, -2 plus 3 root 5 because that's the larger number, and we go in order from largest to smallest. Now how could I use my calculator to double check our work here? Well, to double check, let's look at -2 minus 3 root 5. So let's jump into the calculator here, and let's get a decimal approximation for that. So to get out of the graph and get back to your regular screen where you can do your addition and subtraction, you go second, quit. So let's check. -2, you need to use your negative sign there, not your minus. Now we use -3 square roots of 5. Okay, and hit enter. So our calculator is telling us that this is a good decimal approximation for -2 minus 3 root 5 is -8.708, etc. I don't think we need it quite that big. Okay. Now let's go ahead and do the same thing for -2 plus 3 root 5. So -2 plus 3 root 5. So let's jump back into our calculator. Now some of you can just scroll up and edit your response here. I'm just going to put it back in again. Plus 3 square roots of 5. and here we get 4.708, etc. So let's pop that in. Now what we're getting at here is we're going to be able to check our answers to make sure they're right. Now our calculator does not convert to radicals like it does from decimals to fractions, so I'm just going to have to go after my graphing to see what's going on here. So again, we want to graph this equation, and when we graph this equation it has to be set equal to 0. So my original was 2 times the quantity x plus 2 quantity squared equal 90, but I need to subtract 90 and get it set equal to 0 before I can graph it. So let's again jump back to your calculator. Let's go y equal, and of course clear out what we have there. So we'll have 2 parentheses x plus 2 quantity squared, and again I have to subtract 90 because I have to have it set equal to 0. Let's go ahead and graph this. Okay, so I can see where it's crossing here. -1, -2, -3, -4, -5, -6, -7, -8. It's crossing somewhere between -8 and -9. Okay, well that's interesting. Well, here's my answer over here was somewhere between -8 and -9 right here. So that kind of is some support for that, but it's not a guarantee. So let's go ahead and on your calculator, let's figure out exactly where that point is. So we'd go to second, calc, it's right above the trace key. We want to go towards 0 because we want to know where it crosses the x-axis. And it says left bound, so I'd arrow over. I could either arrow over, or I know from counting that to the left is a -9, so I could actually put -9 in on my keyboard and it would automatically go there. On my right, I also know that that's -8, or you could just arrow over, and that's good enough for a guess. And look at what my 0 is here. It's -8.708204, etc. So let's go ahead and compare that to what we have for our decimal approximations. So again, we're just checking our work here. So as we look at this, we can see that this matches that first solution, -8.7082, and of course this is rounded 0.04. So this verifies that my solution that I have here matches my solution here. So that tells me that that's a correct answer. Now if we were to go through and do the right-hand side, for this right-hand side we would match with our decimal approximation what this value is, and we can see it's between 4 and 5, and we can go through and do the second calc feature again to verify that. So everything that we're looking at here, I can double check with the calculator. Sometimes the calculator will give me nice integers, sometimes it won't. Now the calculator also fails us in another instance that I'll bring up next. The calculator gives us some information about what kind of solutions I am going to get, but not what the actual solution is. So let's go ahead and look at something like x plus 5 quantity squared equals -49. The first thing I want to do is I want to graph this. So if I graph this, it's x plus 5 quantity squared, and then I would have to add the 49 across to set it equal to 0. So let's go ahead and graph this and see what information this can provide. So y equal, clear out the old function, use our parentheses, x plus 5 quantity squared, and then remember we had to add the 49 to get it set equal to 0. And I think we're going to have to adjust our screen here. If you notice, nothing shows up at all. There's nothing on here. So you might say, well wait, there's no graph then. Well, what we can do is we can do to zoom, and again you could do your window as well, but we can do all these different zooms. And I think what we want to do here is at least try zoom standard or zoom square. And sometimes what this does is it goes and tries to find the graph for us. And it's working up here, you can see it didn't find the graph. So I think we're going to have to expand this window out. I'm good with the x values, but for our y values, let's take our y max and let's go up to 100 and let's see if we can find anything. Ah, there it is. So there's our nice little graph, and what this is telling us is it never crosses the x-axis. And because it never crosses the x-axis, that means there's no real solution. So all of my solutions that I get here will have to be complex. So again, just graphing this very quickly already tells us something. It didn't help us solve it, but it told us right away this never crosses the x-axis, so there's no real solution. So this never crosses the x-axis. These three dots in the shape of a triangle mean therefore there is no real solution. There's a complex solution, but there's no real solution. So now we need to go find that real solution, but knowing this to begin with from the graph is really helpful. So the way that we would start this problem is we would use the same square root property that we've used before. So x plus 5 quantity squared equals negative 49. I would go ahead and take the square root of both sides, and I have x plus 5 equals, because the square and the square root cancel each other out. Now the square root of 49 is 7. The square root of negative 1 is I. So what I get here then is plus or minus 7i. Complex numbers. Then I'd go ahead and subtract 5 from both sides, and I'd have x equal negative 5 plus or minus 7i. Now I can't check this on the calculator, but it's a complex number and our calculator only graphs in the real number system. So the fact that this never crosses the x-axis tells us there's no real solution, and here are my complex solutions that go with that. Now remember, in my math lab, you'd need to write this x equal negative 5 minus 7i, negative 5 plus 7i. A little bit of a difference there. So when you're doing these problems, each one is going to be a little bit different, but one thing that you can do all the time is to graph these to get an idea of what types of solution. Are you going to get one solution, two solution? Are you going to get zero real solutions or two complex solutions? So a lot of times, again, you'll be solving and asked to solve the quadratic equation using any means that you can, but one thing that I would always recommend is graphing them first. Now in order to graph this problem, of course, we need to make sure that it's set equal to 0. So let's go ahead and graph 6x minus 4 quantity squared, and then we'd subtract over the 35 and have it set equal to 0. So let's go ahead and graph this with your calculator real quick. So here we go, y equal, in parentheses we have 6x minus 4, and then quantity squared. And on this one we had to subtract the 35, so let's go minus 35. We might have to readjust our viewing screen here. It just kind of depends on how things will look. I can definitely see that I have over here the left endpoint and the right endpoint in terms of my intercepts on the x-axis, but I might want to see a little bit more here. I want to go down further on the y-axis. That way I might be able to see where the vertex is. So y min, let's go negative, I don't know, let's go negative 20 there and see if we can see it. Since it was minus 35, I kind of think we're going to have to go a little lower. And then I probably want to spread out the x values a little bit too. So let's go negative 40 here. And then I want to go back up to my x's. Most of the graph occurred between negative 1 and 2. So I can see down here in this screen, maybe I could go negative 2 to 2 here, so I can really get a nice view and see what's going on with this graph. So there we are, we're hitting our minimum point right here, a vertex, and then it's crossing here as well. So let's go ahead and pull this in between our lecture notes, and then we'll kind of make some comments about intersects and some things like that. So the first thing I notice when we look at this graph is that it crosses 2 times. which is the most number of times a parabola or quadratic equation can cross. So what I have here is a solution or a zero or a root. They all mean the same thing. Then I have another solution over here. Now remember, when we changed our scale, we went between -2 and +2. So that tells me that the solution over here is between 0 and -1. And you know, in fact, I think I'll write that -1 and 0, because we always want to have left endpoint and right endpoint. And then this solution is between 1 and 2. Well, this will come in handy to remember these numbers, because I know these are where my solution should be. Now let's go ahead and look at our table back with the calculator as well. So we go to second table, and again, I already have an idea where my solutions are. They're between -1 and 0, and if you notice, my y values switch from positive to negative, and then they switch again from negative to positive from 1 to 2. So that tells me that's where my root is, because my graph is going from the negative direction down here up here into the positive. So when you have that switch from positive to negative or negative to positive, that means a root is somewhere in between the two x values. So let's pop these in and make those comments as well. So here I have this change from positive to negative, so that means there's a solution between x equal -1 and x equals 0, which our graph showed as well. And then I see that I have another change here, so I have another solution between x equals 0 and x equals 1. So again, solution, root, 0, they all mean the same thing. And again, that happens because I'm switching from positive to negative and then from negative to positive. Well, let's go ahead and look at our graph again, and then let's go ahead and go to using that 0 function on your calculator to figure out what our solutions are. So again, on our graph, we go to second calc. We're going to use the 0 function. It's option 2. And see where it says left bound? I want to find this root first. And I can either arrow over until I'm to the left of that point, or I could just type in -1. So -1. And I know my right bound is 0, so I could type that in as well. So I know I have a solution between there. Now with the guess, if you want to, you can move up here, or you can just leave it as is and hit enter. And that's telling me one of my zeros is right here at -3.193466. And then I could do the same thing over here to find my other 0. I'm just going to go after the 1 0 right now because I need to find exact answers anyway. So I'll be able to check one of them. Okay, so there's one of my solutions that I can see here. Now what I can do is solve this by hand to double check my answer. So my original problem was 6x minus 4 quantity squared equals 35. So to get started, you go ahead and take the square root of both sides. Whatever you do to one side, you do to the other. When I square the square root, I get the radicand back. 35 does not have any factors that are perfect squares, so I need to leave that under the radical. I can't simplify that any further. I'd add 4 to both sides. So I have 6x equals 4 plus or minus the square root of 35. And then of course divide both sides through by 6. So I have my solutions here. X equals 4 plus or minus the square root of 35 over 6. Now, it might be tempting to cancel the 4 and the 6, but remember you can't because the 6 is also underneath the square root of 35. So my math lab, you don't have the plus or minus key, so you would have 4 minus the square root of 35 over 6 is one solution, and 4 plus the square root of 35 over 6 for your other solution. Now also, we already knew one of these solutions was a negative 3.193466. Let's go ahead and check this one on the left on our calculators. So I'm going to go back to my screen. Need to have this in parentheses, 4 minus the square root of 35. And I'm dividing that by 6. So it looks like that matches with what the calculator said. So let's go ahead and paste that in, and then we'll go on to our next problem. So I know the left endpoint is right. I'm pretty confident about the right endpoint. If I wanted, I could go through and double check both of them, but I don't think I need to do that. But you could if you were interested. So notice this negative 3.193 matches this value right here as well. So let's go ahead and it's probably more just the wording. It's not as complicated as it makes it out to be. It's more just the wording, and we'll look at a couple of these. So here, I think this is associated with problem number 9 or something similar to that in your homework set. It says determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. Then write and factor the trinomial. Okay, so this is called completing the square. So the reason it's called completing the square is we start with an expression x squared plus 18x, and we want to know what number should go here in order for me to eventually write this as a perfect square binomial. Okay, so we're called completing the square. Well, the way this works is you always take half of the linear term. This is called our quadratic, and the coefficient in front of this is 1. This is called our linear term because it's just x to the first, and our coefficient is 18. So this is called our linear coefficient. What we do is we take half of 18, and that's going to go right here. Now, after we take half of 18, I put that on the end and I square it. So the way this ends up looking then is x squared plus 18x, and then half of 18 is 9, 9 squared is 81. So if I were to FOIL this out, x plus 9 times x plus 9, or use the box method on it, I would get x squared plus 9x plus 9x plus 81, which of course is x squared plus 18x plus 81. So what I did is I found the perfect value to add to this to make it a perfect square binomial. So this first says, what is the constant that should be added? This is the constant that should be added. So that's where we get the value for 81. We take half of the linear term and square it. Write the trinomial. That's when we include the other terms as well. And then factor the result straight from here. So these are pretty straightforward after you see a good example to go with them, but when you just read them kind of how they're starting, it's not as straightforward. Now sometimes you could get fractions or decimals here, but the process doesn't change at all. So let's go ahead and look at one of these problems where we're working with a fraction perhaps. I'll pull one right out of my math lab. And again, this will probably have the solutions included with it because that's the only way that I can get all the different parts to the question to show. So this one will include a fraction. And we'll go over how we get each of the solution parts to this. Now if you're not good with fractions, make sure you grab your calculator because that will be a helpful thing to have as well. So again, determine the constant that should be added. Well, we're starting with x squared minus 3/5 x plus, and this is what I'm trying to figure out, the constant that should be added. That's what goes in this blank right here. Well, to get the constant that should be added, what we do is we take half of the linear term. So we take negative 3/5 over 2. And that is what is going to be half of that linear term. Now remember, this goes directly down to this piece right here. But we can't leave it as a layered fraction. So let's grab our calculators and let's take -3/5 in parentheses and divide it by 2. So you go second quit if you're in your graphing screen still. And I'm going to put in parentheses -3/5, close parenthesis, and then divide that by 2. Now we don't want to work with decimals, so we can switch this to a fraction by going to math, frac, converts it to a fraction, and we get, enter one more time, -3/10. So half of a -3/5 is a -3/10. And I will pop this into our work in case you want to see how to do this in your calculator again. I'm going to paste, there we go. And again, this is how you get that value of -3/10. So that's going to go right down here. So the minus sign is already there for me, so -3/10. Now what I do is I take this value of -3/10 and I square it. So I take this value, -3/10, and I square it, and that's what goes on the end. So rewriting this, I end up with x squared minus 3/5 x plus -3 times -3 is 9. 10 times 10 is 100. So here's that 9 over 100. Comes from right here. Here's the trinomial rewritten. And then factor the result is right here. And again, the first number we find is that 9/100ths, and that comes from squaring half the linear term. So we've gone through a lot of problems, but I think that's pretty good for this lecture. We will have a second part to this lecture with a lot more work problems shown. We'll also be looking at the quadratic formula in the next lecture as well. So please remember to watch both lectures before you attempt the homework, so that way you have a big, broad background on all the different types of problems that you can use here. As usual, if you have any questions, please let me know. I'd be happy to help.